That is the most important topic from this chapter. Any one question that has to come, it will be photoelectric effect. This is a very, very important topic. Now see, we'll start with that only because in this lesson, you mainly have photoelectric effect and some portion of de Broglie's wavelength, which we write it as de Broglie wavelength. You must have heard of these terms. So that we'll complete. Rest of the portions are deleted. Like in your notes, some notes I have sent you on WhatsApp, modern physics notes are there. So that has all the 3 lessons. Just check it on WhatsApp once. If anybody is there who was added after I have sent it, let me know, I'll resend it. Or text me personally if you're not getting it, I'll share it. I'll share the notes because those are very good handwritten notes. Every point of NCERT is covered. See, all these 3 lessons, they have so much part of theory, so much part of theory is covered in that. You have numericals, but these are such scoring lessons that even if you learn the theory portion, major part will be covered of your syllabus. So it's better you learn the theory part here, pay attention to all the definitions and everything. Now class, it's obviously very difficult to write every definition in the class. So what we'll do, we'll be just studying and discussing the topics here in the class, and rest of the portions you will go back and check it into your notes. Here I'll be discussing everything. No need to worry about the notes. All the handwritten notes have every content of it. Now see, starting with the first concept is that, see, if I just draw a larger section of a wire, suppose I have drawn this section of a wire. Now see class, just a second, just. So dekho, here suppose this is a thicker cross section area of a wire. So the wire will be having electrons. Class, do the understanding part well here. Do not worry about writing part. Even if you do not write down from this won't harm you. You have the written notes on your WhatsApp chat. Pay attention in understanding here, and wherever you're not able to understand, ask me, because here, as I've told you, now see, electrons are there. So these electrons are present. Then positively charged ions are also there. And when we discussed current electricity, that time also I had discussed it with you that electrons are colliding among themselves. They are colliding with the positive ions, and they are, as well as they are colliding with the walls of the container. Right, container, you can say wire, you can say wherever electrons are moving. Now class, some of these electrons, no, these are known as free electrons. Some of these electrons are known as free electrons. So free electrons does not mean that these free electrons are just randomly moving in the sphere. When I say free electrons mean that if these electrons have some criteria and you fulfill that criteria, then only the electrons will become free and available for conduction. Understood? It's like passing the exams. Suppose, let's say out of 100, let's say 33% is passing mark. So the student who will obtain a 90%, the student who will just obtain 35%, both will be considered as pass only. There will be a difference in the marks and rest of the things that I'll tell you. But here, basic thing is that this only the person who is scoring just 34% or 35% or even 33.5%, that person is considered who has cleared the exam. And the person who is getting 95%, 96%, the person has also cleared exam. But if a student is scoring, let's say 20%, or even 32%, we'll say the person has not cleared his exam. He has failed. So this 33% becomes the criteria to pass the exam. Same thing is in terms of these electrons. These electrons have the tendency to become free. The student had the tendency to go through to the another higher level grade. Similarly, electrons have the tendency to become free electrons for conduction, but they have certain criteria that has to be fulfilled. Like in our scores, suppose physics, chemistry, biomaths have some scores that will allow your ultimate score to become 33%. Similarly, electron will be having certain value of wavelength, certain value of frequency, certain value of energy, certain value of potential. When these values are met, then only we say the electron will become free and available for conduction. The way we say, no, a person who has scored, a student who has scored 32% marks only, the person has not passed. Why? Because the criteria for passing minimum marks required is 33%. So same way here, the minimum wavelength that is required to eject an electron from the metal surface, it is known as threshold wavelength. Let's say an electron has 10 to the power minus 3 meter as the threshold wavelength. So until and unless 10 to the power minus 3 meters or more also, like you can get 40%, you can get 60%, you can get a complete 100%. This is not a criteria. Minimum is 33. So same way here also, minimum a wavelength is, for example, let's say 10 to the power minus 3. So this has to be met. This wave frequency, this is known as threshold frequency. The minimum energy that is required, this is known as work function. This is known as work function. Minimum potential that is required, it is known as stopping potential or cutoff potential. These terms will come, and these have been clearly written in your notes. Understood? So if certain criteria, these are fulfilled by the radiation that is falling on the matter, then these electrons become available for conduction, and from the bounded state, they become free for conduction. And these types of emissions that are occurring, the way electron is moving, so it's not necessary that a light has to be present. These emissions are of 4 types. Basically, they are of 4 types. See, one is your thermionic emission. If you are using heat energy, any form of heat energy, any source of heat energy you are using, and then the electrons are getting ejected, then you will say this is known as thermionic emission. If cold cathode, do you understand? Cold cathodes are basically unheated cathode rays that are present. So they are used in the circuits and all. So if cold cathodes are emitting electrons, from cathode to anode, the electrons travel, then we say this is what written on the screen, field energy emission. Now see, electrons are also moving. So it can happen from this metal surface, this electron pushes this electron and it collides it, and the collision results in the ejection of this electron. So we say that is secondary emission. And if your light rays are falling on the electron and the electron is getting ejected from the metal surface, it is known as photoelectric emission or photoelectric effect. Out of all these 4, this is the one which you have to study in detail. Now see, so here I had already written work function is minimum amount of energy required by an electron to just escape from metal surface. And here the rest of the things, the way it was similar. So in photoelectric effect, what will happen? When light of suitable frequency wavelength strikes a metal surface is present. This is having some electrons. So out of all these electrons, the electrons that are present, which are free electrons, some will be free, some will be bounded. So free electron, let's say these 2 are free. So if these electrons are given necessary frequency, necessary wavelength, right? If these are given necessary frequency, necessary wavelength, so these will be ejected from the surface. So when light of suitable frequency strikes a metal surface, electrons are emitted from it. This is known as photoelectric emission. I think quantum physics part you have had in your 11th standard when you were studying structure of atom in chemistry. You had all these, right? So photoelectric effect is when light of suitable frequency strikes a metal surface and the electrons are emitted from it. This phenomena is known as photoelectric emission. Now these electrons which get emitted from the surface, these electrons are known as photoelectrons. These electrons are known as photoelectrons. Fine. Now, some experiments were conducted to see effect of kinetic energy, to see effect of frequency, intensity, certain things. But that is a different thing. First, just understand the basic. I'm repeating it. Any doubts, let me know. Then you can note it down. Certain wavelength, minimum wavelength that is required for an electron to just escape from metal surface is threshold wavelength. That minimum frequency is threshold frequency. That minimum energy is work function. That minimum potential is stopping potential. And we usually represent these symbols. See, if we put a naught, that will become for threshold wavelength. Frequency naught, threshold frequency. Work function, we use this symbol phi. Here I've written. All right. And if you want to convert 1 electron volt into joules, that will be by multiplying 1.6 into 10 to the power minus 19 joules. Noted till here, then I'll discuss that effects of those experiments, intensity and amount of electrons and all. Noted from here. And do not worry about the details of it. Definition, the detailed definitions are there in your notes. This is just so that you can tally up with the points. Yes, class. Now see the experiment part, no, that I was mentioning you. See, this experiment, how was this setup done is not a part of your syllabus. You just have to know about the results. In short, just you can see the apparatus of vacuum tube was constructed, cathode was there, anode was there, and an outlet was made for the light rays to pass. And as the light rays struck up this cathode, the electrons got emitted and they moved from cathode to anode. Now, while the electrons moved, ammeter was also connected, voltmeter was also connected, rheostat was also connected to regulate the current along with the key and the battery. But what will be the variations of intensity in all these things? Now see, first is effect of photoelectric current with intensity. So see, intensity and photoelectric current are directly proportional to each other. This means as the number of photoelectrons, as you increase the number of electrons, as you increase the intensity, number of electrons also keep on getting ejected. Let's say you have increased the intensity. Now more number of electrons will get added here. So as the number of electrons get added up, as the number of electrons become more, so both are proportional to each other. So basically what I write now, photoelectric current is directly proportional to the intensity. Now see, photoelectric current is directly proportional to intensity because number of photoelectrons ejected, this is directly proportional to intensity. So number of electrons proportional to intensity, therefore photoelectric current is directly proportional to intensity. Class, these results are important. The experiment setup is not important for you. Even if you do not revise it, that will be fine by yourself. But these results of these experiments, like the graph plotting and writing about it, this is important. So notes have these things, everything in detail, but let us discuss over here. So this was stopping potential or cutoff potential, which I was saying. Differences or unique points that have not been discussed over that time was that this is a retarding potential. You must have heard of retardation in 11th standard, negative acceleration or decreasing acceleration, right?
Yes, ma'am.
Yes.
Okay, so that retardation was what? Negative acceleration, that was decreasing. So same thing, this is retarding potential. So potential that is decreasing. So value of retarding potential at which photoelectric current becomes zero is called stopping potential for a given frequency of incident radiation. So same value, you have a same definition it is. See, when you are understanding the definition, no, in simpler term, it's better you just remember this thing. Minimum potential, like cutoff, but cutoff potential means what? Cutoff you must have heard of. The cutoff for JEE entrances is this much. NEET cutoff is this. So cutoff was what? Minimum marks are this. Let's say suppose 600 is the cutoff for NEET. So the person who is getting 650 will also be considered who has cleared the cutoff, and the person who is getting 601 is also getting. So cutoff is what? Something that is set. Minimum, this barrier has to be crossed off. So this is like this only in simpler terms, but for remembering, you should learn these definitions only. Now graph part is important. See, photoelectric current versus potential graph when you plot. Stopping potential is there. So stopping potential is the negative potential. Negative potential. Now this graph says what? This and class, try to learn these graphs as it is. Because here, no, as it is, graphs are as in your exam, as it is. Same thing. And here, this can be asked to you regarding the intensity, I3, I2, I1. Here, see here, when the stopping potential is increased, gradually, you will see current is also increasing. Fine, current also increases, but a point is reached where no more current is increased for all the values of stopping potential. And if you keep the frequencies fixed, then stopping potential for a particular apparatus will be the same. Let's say minus V naught. This is negative, so we had to plot it here. We could not plot it. This is the anode graph, but we cannot plot it on the x-axis, positive x-axis. So we have plotted it on the negative x-axis because y-axis is having your current. Now C class. Potential, it is happening what? This current is slowly increasing, and this maximum saturation point is reached when no more current is increased. So intensities are different. If you increase the intensity, graph difference will occur that from here there it will be having a starting point, but the current's value will be different, a little more, but then again it will become saturated. Then if you increasing intensity, first graph, remember the first graph, increasing intensity increases photoelectric current. So if I increase the intensity to I3, let's say, so I3 will increase the photoelectric current. It is more than I1. Look here, I1. This is I3. But again, from its maximum point also, saturation current is reached. Saturation currents have different values if intensities are different class, because we know intensity and photoelectric current depend on each other. See, if you change this, if you, in contrary, keep intensity fixed and change frequency, this is the graph that you get. See, you're not changing intensity. Intensity is kept fixed here. Intensity is kept fixed over here. So what is happening when you are keeping intensity fixed? All the current will reach one point, saturation point. And here now potential will be different because frequencies are not fixed. One more formula you have, which you have to remember, it is of kinetic energy, that if you multiply the electronic charge, E is the electronic charge, with the stopping potential, you get the formula of maximum kinetic energy. Or kinetic energy, wherever in your physics you're getting potential value, you can directly multiply it by the electronic charge and get the value of kinetic energy. This is not of much significance right now. When we'll do Einstein's equation, that time it is very helpful. Right now, just focus on the graph. In between the stopping potential topic came, that's why I had written it. Otherwise, these are the two graphs that are very important. Now, thresholds, frequency definition, I have already discussed it with you. Minimum value of frequency of incident radiation for which photoelectric effect occurs is called threshold frequency. Now, two more graphs you have. Two basic graphs you have between kinetic energy and frequency, and kinetic energy and intensity. So kinetic energy and frequency are also directly proportional to each other. Kinetic energy is directly proportional to the frequency, but it is independent of intensity. And class, this is an important question, important point from question view. Why independent of intensity? One question was there in your previous years which had the value of kinetic energy and was asking the values of frequency and intensity. So for frequency, it got doubled. Somehow there was some other data were also given. But intensity, many students kept on calculating. They used power per unit area, something that could relate intensity. They just had to apply this graph. You know that the graph says it is independent of intensity. So you have to apply it in the numericals as well. Fine. So kinetic energy is independent of intensity. These graphs are very important, class. These graphs are very important. I'll repeat these graphs. And you have some questions are there which says laws of photoelectric effect. Whatever you have studied till now, no, I'll just select few topics, few points, and I'll tell you what are the laws of photoelectric current. Firstly, let us revise this. See, photoelectric current is directly proportional to intensity. Number of photoelectrons increases, photoelectric current increases. Potential and potential versus current gradually increases for a particular stopping potential and reaches a maximum saturation point from where now no more current is increased. This point is known, the current's value is known as saturation current. So frequency remains fixed, and class, this is asked, I1, I2, I3 will be given, and it will be asked to you which intensity is greater, because that will help checking whether you know the first graph or not. Fine. Then skip this part, coming to the third graph, that when intensity is fixed and current will also be fixed. So current will increase, but all of the currents will reach the same point. And kinetic energy is independent of intensity, but directly proportional to frequency. Now I'll tell you the laws of photoelectric effect. If a separate question comes, no class, mention it. In your notes, it will be written properly. So do revise it from your notes. Now see, we did know the graph, photoelectric current versus intensity. That is actually the first law of photoelectric effect. Then secondly, we talked about threshold frequency, the minimum frequency which is required. That is your threshold frequency is the second full law of photoelectric effect. You have studied these 2 points as well as the third point. These 2 graphs, no, just now we have seen here the graphs regarding the kinetic energy and the intensity. These 2 graphs are your third law. Law in the sense you'll have to mention kinetic energy is directly proportional to frequency and independent of intensity. And it's better if you have time, plot the graphs for all of it. And last point is just new. This says that photoelectric emission is just an instantaneous process. Instantaneous emission means light ray has struck the metal surface. And it is not first the light ray is getting, then electrons threshold is getting crossed, wavelength is getting crossed, and then the electron is getting ejected. No. Light ray strikes within 1 nanosecond. 10 to the power 9 is what? Within 1 nanosecond, this electron gets ejected. Obviously, it is an instantaneous emission. Otherwise, so many processes would have been so slow. So 4 laws, the first graph which we did, it is actually one of the laws. If it comes separately as a graph, you will write it as separately as a graph. If it is asked to you under the laws, you will mention it under the laws. Laws are asked, you will have to mention it. Threshold frequencies definition, kinetic energy is both graph, and photoelectric effect is an instantaneous emission. So these were the 5 important graphs from which you had the law of photoelectric effect. Class, tell me, is this clear to all of you?
Yes, ma'am. Clear.
Yes, ma'am, clear.
Okay, good then. I hope others also it is clear. Those who have not responded, please note it down from here. Any doubts? Any doubts you have, then ask me in between.
Ma'am, can you just explain this graph again? Intensity one.
Yes.
Can you just explain this graph again, ma'am?
Yes,
Current.
yes. See. This is a linear graph. Linear graph means x is directly proportional to y-axis. Both the axes are directly proportional to each other. So straight line graph means, suppose I choose this point I have taken. This is
Hmm.
first point. So this is having some value from here. This is having some value from y-axis. Now I have taken another point. Here, intensity I have increased. You can see from the x-axis, this value is more than the previous one. But look at
Yeah.
the y-axis. This value is also increasing. Again, you keep on choosing points. You'll notice as you're keeping increasing intensity, and you will notice that electric current, photoelectric current is also increasing just according to it. You double intensity, amount of photoelectrons double, amount of photoelectric current becomes double. Clear?
Okay. Thank you.
Ma'am. Ma'am. Is someone asking anything?
Yes, ma'am. I have a doubt.
Yes, yes, Asta, say.
Ma'am, PE current is potential, nahi, what photoelectric current or photoelectron current?
PEE, when I write, that is photoelectric effect. Basically, it is photoelectric current only. Electrons are known as electrons. So the current is known as photoelectric current. It is just to distinguish that this is not just the normal current. This is the photoelectric current specifically that is occurring because of the light radiations. All right.
Yes, ma'am. Ma'am, can I leave half an hour early from the class before attendance?
Why?
Ma'am, actually, mom is traveling today, so I have to go to the airport to drop her.
Okay, Asta, just text me once before leaving. Okay.
Yes, ma'am. Thank you, ma'am. Ma'am, could you scroll in? No, ma'am, the formula below the box. Oh, yes, done, ma'am.
Now see class, you have Einstein's photoelectric equations. So this is one basic simple statement. See class, work function we have discussed that this is a minimum energy. So in a metal surface, the minimum energy, that is work function, is present, and total energy is also there. Class, total energy is directly proportional to the frequency. Total energy is directly proportional to the frequency. So if you remove the proportionality sign here, you put a constant that is known as H. Here you get the constant which is H. E is equal to H nu. Nu is the frequency, H is the constant which is known as Planck's constant. So value of H is 6.63 into 10 to the power minus 11 joules seconds. This value all of you have to remember. This won't be given in the question, but it will be used everywhere. Fine. So this is Planck's constant. Even it will be used in your upcoming lessons as well, not only for dual nature. So this is Planck's constant. Now see class, frequency can be written as, remember, frequency and multiplied by wavelength is actually speed. So frequency can be written as C by lambda. So here the formula becomes E is equal to hc by lambda, where C is the speed of light. Speed of light, I hope all of you must be knowing, 3 into 10 to the power 8 meter per second. Lambda is the wavelength. E is equal to h nu. E is equal to hc by lambda. But this is not the Einstein's photoelectric effect equation. This is the energy of photons. E is equal to h nu, E is equal to hc by lambda. These are what? These are the energies of the radiations that are falling. But what Einstein observed was work function is there for every electron. So it should have happened, no? All the total energy, that is all these h nu, hc by lambda, all these energy should have been equal to the work function. But it was observed that the electrons move and then get ejected from the metal surface. If there is motion of electrons occurring, what type of energy comes into action due to motion? Kinetic energy. Yes. So he said that not only work function, there will be a presence of kinetic energy as well within these electrons. So this is known as the Einstein's photoelectric equation. Incident ray is there, bounded electron is there. To make this electron as a free electron, you have some incident photons which are striking on this, and then the total energy will be sum of kinetic energy and work function. This is actually your complete statement. Now see class, this is just the formula that is sufficient for your calculations. But see, you can use this formula in so many ways. I'll tell you. See here. Energy, just now I have told you, you can write energy as h nu. You can write energy as hc by lambda. Whatever is given. Suppose in your exam, in your question, frequency is given. So use h nu. If hc by lambda is given, lambda is given. So use hc by lambda. Now kinetic energy maximum can be half m v max square also. Half mv square formula of kinetic energy, as well as one you have noted in between, EV naught. So if potential is given, stopping potential is given, and you want to use this equation, then how will you use? So you will prefer EV naught as the formula of kinetic energy. And then work function. See, work function is minimum energy. So this time, instead of writing h nu, you will write minimum frequency. What is this minimum frequency? Threshold frequency. For normal energy of incident photon, you had normal frequency and normal wavelength. For work function, that is minimum energy, you will use minimum frequency and minimum wavelength, hc by lambda naught. This is distinguishing, this lambda naught is distinguishing from the normal wavelength. Now see class, you can use any of these formula, any formula you which you want to answer. Like see here, let's say you can write it as h nu is equal to EV naught plus h nu naught. Whatever is the suitable equation for you, you can construct it now. So if many times EV naught is asked, kinetic energy is asked, then you can write it as h take common, nu minus nu naught, or you can write half EV naught as h HC common, 1 by lambda minus 1 by lambda not common. Or you can write half mv square is equal to h nu plus, sorry, not plus, h nu minus work function. This also you can write h nu minus work function, right? So half mv square is equal to h nu minus phi naught also you can write. Whatever is given in the question that you can use depending on the equation. Like let's say wavelength is given. So hc by lambda would be equal to, if velocity is given, you will use half mv square. If frequency is given, minus h nu plus h nu, half mv square plus h nu. Whatever is given to you, you can construct it. This will be more clear if we practice numericals. Note it down, then I'll show you some numericals. See, this question says that what is the frequency of a photon whose energy is 66.3 electron volt. So now energy is mentioned to you, frequency is asked, and energy is also given in electron volt. This is not the SI unit. So this energy 66.3 electron volt, we'll convert it into joules. So this will be, we'll multiply it. This will multiply it, this will multiply it by 1.6 into 10 to the power minus 9. Yes, so 66.3 into 1.6 into 10 to the power minus 19 joules. This will be the energy. Just now we saw formula S is equal to h nu. From here, the frequency will be E divided by Planck's constant. Energy is 66.3 into 1.6 into 10 to the power minus 19, and wavelength is, Planck's constant is 6.63 into 10 to the power minus 11. So this will get cancelled. 1.6 something you'll get into 10 to the power. Just check, I think -4 or something. See, this much hertz will be your frequency. Note it down. One more question I'll discuss. Monochromatic light of frequency 6 into 10 to the power 14 hertz. Nobody sent me any answer till here. Power emitted is 2 into 10 to the power minus 3 watt. 2 into 10 to the power minus 3 watt. And frequency is given 6 into 10 to the power 14 hertz. Now see here. It is asking you energy. So energy can be calculated by just using frequency. E is equal to h nu 6.63 into 10 to the power minus 11 into 6 into 10 to the power 14 hertz. So how much will be energy? 6 into 6, 36. Take it as 37 because 3 is also there, no? And this was 14. So minus 3, 10 to the power minus 3 joules. Then it says how many photons per second are emitted. So number of photons emitted are power divided by energy. So power is 2 into 10 to the power minus 3. Actually make it as 40 only. Answer will be around 39 point something only. Someone just cross check and let me know the exact answer. I'm writing it as 40.
Ma'am, it's 10 raised to plus 3, right?
Oh, sorry. Yes, this is 10 to the power plus 3. So 2 into 10 to the power minus 3 divided by, this is 40 into 10 to the power 3, right? So see whatever answer you get, number of photons will be this. When is equal to P by E, this was what had to be used. Note down this. Yes, Asta, you can leave.
Thank you, ma'am.
See class, this graph is there where it shows variation between stopping potential and frequency. So stopping potential and frequencies are linearly proportional to each other. So as the potential increases, frequency also increases. But when you extend it, it intersects somewhere. Now, why is this point written as minus phi naught by E? Look here, EV naught is equal to H2 minus phi naught. If you divide all this entire equation by E, electronic charge, here this E will get cancelled. We'll be left with V naught. From here, we'll be having H by E into frequency minus phi naught by E. If you compare it with the main equation, y is equal to mx plus c, you will see that this equation is, from this equation, slope is h by e, and speed of the intercept, y-intercept, this is the y-intercept, no, from the cut on the y-axis, that is minus phi naught by e. So this graph can also come to you to draw exact. Note it down quickly, then a very small topic is there. Then I'll end the class. Do text me done once completed. Okay, if all of you have completed, let's just complete this small topic, de Broglie wavelength. If anyone is writing, let me know. I'll stop. See, de Broglie wavelength basically connects with your particle nature. That the waves that are associated with material particles are called matter waves or de Broglie waves. Now, see, E is equal to mc square. You must have heard of Einstein's equation of theory of relativity, and E is equal to hc by lambda also just now you have seen. So both the energies are same equated. mc square becomes equal to hc by lambda. C squares and the C gets cancelled. Lambda becomes equal to h by m. V I'm writing because V is general, C is just specific for the velocity. So lambda is h by mv. Mass into velocity. Can anyone tell me what is this quantity, mass into velocity? Mass into velocity. Anyone?
Momentum.
Yes, momentum, correct. Ahmed is also right. This is momentum. So lambda is equal to h by p. Also, you can write this equation. Now see here, h is equal to mv or h by p. Now on what factors does it depend? Lambda is inversely proportional to momentum. If this is the first point, if you take velocity as 0, so 1 by infinity will be 0. It means wavelength will be infinite. So if velocity is 0, wavelength infinite, that is not possible. It means you can have de Broglie wavelengths only when the velocity is non-zero. That is, the body is not at rest. If it is at rest, de Broglie wavelengths will not exist because of this formula. What are de Broglie wavelengths? I am repeating once again. Okay, let us discuss these 2 points as well. These are matter waves. Matter waves means these are considering wave nature of electron. Dual nature, no, so that second nature is this wave nature. And last one, these are not EM waves. Those electromagnetic spectrum things and all, everything that you have studied, these are not a part of those waves. When you not equate it to EM waves, many properties of EM waves that are satisfied by other rays, these are not satisfied now. So a small topic, let me repeat it for you. Waves associated with the material particles like electrons, whatever are the waves that are associated with it. I'll continue this with atoms tomorrow. Atoms has also the same thing. So lambda is equal to h by p or h by mv. This is the formula for it. And this depends, 4 factors are important that you should remember. Lambda is inversely proportional to momentum. If velocity is 0, then this is not valid. These are matter waves and not EM waves. Class, one more thing. See, kinetic energy is equal to P square by 2m. I don't know how many of you remember, but this was there in your class 11. So this becomes 2 mass into kinetic energy under root. So this also you can use. H by P, so 2m K. You can now put the value of kinetic energy is also half mv square or ev naught. Get it? You can connect all the formulas now once you have this formula. So that's why this topic is very, very easy. Note it down. Any doubts you have, ask me. This is the last topic. Then rest of the numericals practicing from this topic, other topics that I'll discuss it with you in the revision classes, because otherwise questions are endless. Basic questions were these only. Basic topics are these only. Quickly note it down and text me done once completed, and I'll end the class.